Welcome back to the ITANS Hub. Today we will see about K-map in detail. So without wasting any time, let's start. What is K-map in Boolean algebra? K-map in Boolean algebra is a graphical representation used in Boolean algebra and digital circuit design. It provides a systematic way to simplify and minimize Boolean expressions. K-map simplify the Boolean expression in pictorial format without using Boolean laws or theorems. It is generally used for solving the complex Boolean expressions and get the minimum number of logic gates in our circuit. Instead of Boolean algebra, there is one more way through we simplify the Boolean expression and we find minimum number of logic gates. That is, K-map in Boolean algebra. The map itself is a grid-like structure where each cell corresponds to a unique combination of input variables in a truth table. So K-map in Boolean algebra relay on grids or cells, we use it to solve or understand the combination of various inputs. We will understand deeply K-map in Boolean algebra in just few lines next. Now we will see truth table in Boolean algebra. A truth table is a tabular representation of all the combinations of values for inputs and their corresponding outputs. It lists all possible input combinations and the output that results from those combinations. Means, when we put two different types of input in truth table, then truth table gives us a new or unique outputs. As we can see that in below picture. Example of truth table, the truth table for the logical and operator, 2 input and gate. Now we will understand through table. You can see in this table, where A and B both are inputs and B is outputs, you can see when A and B both inputs are 0 then output is also 0, and when A input is 0 and B input is 1 then output is 0, and when A input is 1 and B input is 0 then output is 0. When A and B both inputs are 1 then outputs is also 1. Note K-map is developed by Karnaugh in the year 1953. When we solve any Boolean expression then we generally use simple formula, that is 2 to the power n, where n is number of variables. In K-map in Boolean algebra number of variable can be 2, 3 or more. Let's see one by one in detail. Example. Let's suppose we have 2 variable, then according to formula 2 to the power n, you know already n is the number of variable. Now, example is 2 to the power 2, where 2 is number of variable. Next step to solve 2 multiple 2, that will be 4, where 4 is number of cell and grids. Now, you can see in this picture, where A and B are variables. And here 0 to 3 is number of cells. Generally in K-map counting of cells are started from 0. A equals to 1, is binary, and a bar equals to 0, in binary, you will be seeing in this picture 00, 0, 1, 1, 0, and 1, 1. You might be wondering what is this. So don't worry. This is the binary numbers. 0, 0 is the binary form of 0, and 0, 1 is the binary form of 1, and 1, 0 is the binary form of 2. And 1, 1 is the binary form of 3. Now let's suppose we have 3 variable, then according to formula, here also the use same formula 2 to the power n, I am going to tell you for 3 variables, 2 to the power of 3. Next step to solve 2 multiply 2, that will be 8, where 8 is number of cell and grids. Now, you can see in this picture, where A, B, and C are variables, and here 0 to 7 is number of cells. Generally in K-map counting of cells are started from 0. A equals to 1, is binary. A bar equals to 0, in binary, here. 000 is the binary form of 0, and 0, 0, 1 is the binary form of 1, and 0, 1, 1 is the binary form of 2. 0, 1, 0 is the binary form of 3. 1, 0, 0 is the binary form of 4. 1, 0, 1 is the binary form of 5, 1, 1, 1 is the binary form of 6, 110 is the binary form of 7. Here the most important thing is to notice that counting of cells are quite different, as you can see in both 2 and 3 variable cells. Numbers are not continuous. There is something twist means after 1 we expect 2, but it is not as per our expectation, instead it has started from 0. So we have to remember these sequence of numbers. It is not too tough to remember. One more thing, you have to observe the sequence of binary number means. If we talk about the last cell in 3 variable table, it is 6 and its binary number is 110, we write from left to right means of BC, that is why we found binary number 110 that is equals to 6. Same as this, if we talk about 4th cell, it is 2 and binary number is 010, we write from left to right means a BC, that is why we found binary number 010, that is equals to 2. What is key points of K-map? K-map is nothing but it is just a representation that represent values in tabular format, but it gives more information than any truth table. Through K-map we can minimize the Boolean expression, 2, 3, 4 variables, easily, without using any postulates of Boolean algebra. We can easily find out the SOP, sum of product, and POS, product of sum, form of any given Boolean expression using K-map. It is basically graphical representation of truth table. K-map is basically consists of cells arranged in a grids, where each cells corresponds to a unique combinations. Our journey has not end here. There is some more important things related to the K-map. We will see them in detail in next video. You are still watching this video. Means you are getting these concepts very well. So if you have any confusion related to K-map in Boolean algebra, you can feel free to ask your doubt in comment box. I will solve your problem or doubt as possible as quick. And don't forget to like and subscribe this channel. Here you will learn hard concepts in just few simple words. You can also read these concepts on our website. Our website link is in description. Just open that link and accumulate several information from there. I hope you guys enjoyed this video very much. Till then, bye and keep informed. Thank you.